All right, good evening once again. This is William Seleman. As you can see, today I want to look at numbers. This is mathematics, and this topic it will cover either for grade 8, which is Form 1, grade 9, Form 2, grade 10, Form 3, grade 11, Form 4, and grade 12s. Sometimes you may think that mathematics is difficult. Just simply means maybe you skip this topic because these are early. This is the first topic, either in grade 10, which is Form 3, or grade 8, which is Form 1. So I've brought this topic so that you can catch up. I believe it will be beneficial to you. So, numbers, what do I mean when I say numbers? Let me give you an example of a number. Example of a number. It may sound to be funny, but you'll be surprised. 100. This is a number. Negative 2. This is an example of a number. Pi, which is equivalent to 22/7. This is also a number. When you go further in trigonometry, we will find this symbol E. It's an example of a number. If you have a calculator right now, you can punch on a calculator this E. And then E is equal to, you are going to see the value it's going to give you. Another example of a number I can give, 1/1, which is equal to 1. It is a number, not so, and so on and so forth. So there are many. In fact, mathematics it's all bounded with numbers. Of course, you encounter symbols like the symbol for integrations, some symbols for differentiations, some symbols in computer, whatever, but mostly it's all about mathematics. It's all about numbers. So today I just want us to discuss some type of numbers which we commonly use in mathematics and how we can classify them. Okay, for example, as you can see here, the first one, I have a list of numbers, which is 1, 2, 3, 4, 5, 6, 7. On this one, even if I were to call a grade 1, he can read these numbers the way I've read them. And these are numbers which we always use. In grade 1, we were being given a task, count 1 up to 10. Start 1, 2, 3, 4, 5, 6, count 1 up to 20, count 1 up to something. So at this level now, we need to classify these numbers. These counting numbers, what do we call it in mathematics? The counting numbers in mathematics are called natural numbers. Don't forget, natural numbers. Symbol, something like a capital letter N. Natural numbers. From today onward, kindly know that the counting numbers are called natural numbers. Do I include a 0 here? No, which means a 0 is not a natural number. Have I included any negative number here? No, which means any negative number, it's not a natural number. Have I included anything like a fraction here which is giving me some decimals? No, which means they are not natural numbers. But a fraction like 4/2, we know that the answer is 2. If you have been given this fraction and then you have been asked to classify, is this a natural number? You know that the answer is 2. Of course, it's a natural number. Because even these the same counting numbers. This is a fraction. 1, it's 1/1. 2, this is 2/1. 3, this is 3/1. So, I think on the natural number, everyone is clear. Let me go on the second one. Note that on the first one, the list is endless, counting up to infinity. If I say infinity, meaning counting up to the very bigger number, which we don't know. So it's from 1 to infinity. So if I were to classify the set of natural numbers, I can say that natural numbers, this is a set in set builder notation. This is a set of numbers from 1 up to infinity. This is the symbol for infinity. I think this is the simplest way I can classify natural numbers. The set of numbers from 1 up to infinity, in cross brackets. Let me go on B. On this B, I've got numbers from 0, 1, 2, 3, 4, going up to infinity. So from the first list, on the second one, I've just added a 0. This 0 will make a difference. I'm turning these natural numbers into whole numbers. So in other words, I can say that all numbers, these are counting numbers including a 0. These are counting numbers including a 0. Those are all numbers, symbol capital W. Let me come on the third one, C. On C, I've got numbers from negative. How can I classify the set of whole numbers in set builder notation? In set builder notation, I can say that it's a set from 0 to infinity, or from 0 up to infinity, something like this. Even here, something like this, which means even the 0 is included. On C, I've got numbers from negative numbers, which I don't know, up to, from negative numbers, blah, 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 0, 1, 2, 3, up to the largest positive number, which I don't know. From negative infinity to positive infinity. These are what I call integers. Integers, the same way you know the number line is made up of integers, which means the number line is made up of negative numbers and positive numbers, including a 0. Are we together on that one? Let me move on. I come to D. D, I've got -3, -1, 1, 3, 5, 7. So I've realized that from the set of integers, if I'm skipping one number in the middle, or if I pick any number, okay, any number which is in the set of integers, excluding those numbers which are divisible by 2, then that's the set of odd numbers. Okay, from the set of integers, I'm skipping from 0. I know 0, 1, 1 is not divisible by 2, 2 is divisible by 2, 3, 3 is not divisible by 2, so it can come in. So from the set of integers, if I remove numbers which are divisible by 2, then I'm coming up with a set of numbers which is called odd numbers. Okay, what if I skip these odd numbers? Then I remain with those numbers which are divisible by 2, including the 0. And then that's the set of even numbers. Even numbers. Have you seen the difference between the odd number and even numbers? Those who ask, is 0 an even number? Yes. A big yes on that one. Don't forget, 0 is an even number. They are numbers from the set of natural numbers. From these natural numbers, if I pick numbers which are divisible by 1 and itself, they are called prime numbers. Don't forget, prime numbers, these are numbers which are divisible by 1 and itself from the set of odd numbers, not all numbers, okay? We are together. Then there is this set of numbers. I'm starting from 4. Why have I skipped 1? Why have I skipped 2? Why have I skipped 3? Okay, starting from 4. There are numbers which are divisible by 2 or more numbers. 2 or more numbers. These numbers are called composite numbers. So like if I were to pick 2, 1 is only divisible by 1 and 1 itself. That's 2 numbers. 2 is divisible by 1 and 2. So that's so. It's not a composite number. 3 is divisible by 1. It is also divisible by 2. Sorry, by 3 itself. Those numbers, they are not more than 2. So it's not qualified to be a composite number. 4 is divisible by 1. It is divisible by 2. It is divisible by 4 itself. So it's a composite number. We are sure on this one. There are numbers, fractions which are non-repeating. Those fractions which gives decimal fraction but they end, okay? Square root of 9, it's either positive 1, positive 3 or negative 3. And negative numbers which are not repeating, or any number which can be written in form of a over b, where b is not a 0. Those are rational numbers, okay? Rational numbers. If I've got a number which is not terminating, it is just kept on going, like pi, they just write it to be 3.142, but there are many numbers which follows afterward. So pi, it has got non-terminating, non-repeating numbers. Root 2, if you click on the calculator, it will give you some numbers which are they are not ending. Root 3, same on the calculator, you can confirm. That set of numbers is called irrational numbers. I feel this was helpful for you. Please don't forget to like, share the information. If it's on Facebook, like and follow that page. If you find this video on YouTube, please just follow, like. If it will be on TikTok, just follow and like. Some more videos are coming. You can also drop a comment by asking where you are not clear. Media is open to everyone. I may not attend to your question according to how you expect it, but others will tackle it according to how you want it. I will be also helping you to answer it according to how you phrase it. Thank you for today. God bless you.